Hi there once again, and welcome to another Expresso mechanic tutorial. And in this one we're going to be creating a random floorboard generator. Now this was an idea that was suggested to me by one of my subscribers. His name is Uriah Hill, so a big shout out goes to you, Uriah. And what we're going to be using here to create this is actually the Python generator. Now Uriah had said that he'd used Expresso to try and do this, and he'd not been able to do it, and he'd not been able to find any plugins anywhere that could actually do this either, or at least to his satisfaction. Well, as soon as he suggested it to me, I thought, well, I think that's a job probably for the Python generator, and so it proved to be. And what we're going to be using is a number of different user data here to actually give us artistic control over how this works. So we've got rows here, so we can add to the number of rows. We've also got the floor length, so we can make things bigger using that, or go down to a much smaller level. So we could create something like a bathroom maybe, or take things much, much bigger and go to something like a ballroom. So we've got plenty of artistic control over the actual size of the potential room that this floor is going to fit inside. We've also got a board width control, so we can have very thin slats. If we wanted to do something like a 10-pin bowling lane, maybe you could go very thin and then perhaps lengthen it out so you could get a 10-pin bowling lane. Or we can go much wider with our floorboards if we so wish. We can also control the minimum board length and maximum board length, which again gives us a further degree of artistic control over how things are going to look. But anyway, that's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. In order to make this scene work, I just need two items. The first is a null, which I'm going to rename boards. And the second is the all-important Python generator, and they're the only two things we actually need to bring in. I'll switch to a scripting layout, select my Python generator, and open in Python editor. Okay, at the moment we've got a line which is saying return c4d.baseObject c4d.oCube, which is giving us this cube. We don't need this, so we'll delete it, and we'll also forget about the cube. Now the cube is not even in the object manager at the moment. If I click there, it shouldn't come in, and it doesn't, but it would have done if I'd left the line in and then clicked. We didn't need it, so it's gone, and at the moment the Python generator is red because there's nothing happening in it. That's perfectly fine. We'll just get rid of this here as well, and we can also get rid of this. We don't need it. Get rid of those. Okay, great. So we've got things set up. The first thing we need to do is import random. That's got the actual random module brought in, so we can use the random class, and we'll be using that to generate the lengths of our boards. And then here I'm going to say random.seed and just put a seed value in there. We don't necessarily have to do this, but I'm just doing it to show you, and it's worth doing on odd occasions, but we'll just put that in there. And we can change this value, of course, and it will change things on the screen if we do. We now need to work in our main function. So the first thing here is to set a few variables. So we can say global lengths and positions. They're the only global variables that we actually need. Moving on from here, we can say parent is equal to, and it will be doc.search object brackets, and the object that we're interested in is going to be, in inverted commas, boards. So in other words, we're searching for this null. That's what we're interested in. That's going to become our parent object, and we're actually going to be placing our floorboards under this null. That's what we're going to be doing there. So we've got our parent. The next thing we need to worry about is our parent's children. So we'll say children equals, and it will be parent dot get children. Open close. Now currently the boards here has no children. But that's not a problem. We can still say this. It's just that at the moment it will be equal to none. And that's not a problem at all, as I say. Moving on from here, we'll say frame is equal to doc.getTime.getFrame brackets doc.getFPS. And you've seen me do that many times. Double close. And as we know, this gets our frames from the timeline. So there are our main variables set up for now. There will be another one, but I'll put that in later because we don't really need it at the moment. So we'll start here for now. Moving on from here, we need to set up some user data. So that's our next port of call. Before we move on to the user data, I've just realised I've spelt links wrong. I still haven't booked those typing lessons. I really need to. Okay, great. So that's all good. Yes, the next thing then is the user data. So I'll select the Python generator and add user data. I'll add a group and name it controls and drag it out of this user data here and drop this data in to the controls. This one we'll call rows. The data type will be integer. It will be an integer slider. Steps will be 1. We'll start with a minimum of 1 and a maximum we'll leave at 100, and our default we'll set to 1. And that gives us our first user data there. We'll also clamp the values. So we'll set our sliders minimum and max to 1 and 100. That's our first piece of user data set up and ready to go. And we can move on from here. So we'll add some more data. This will be floor length. Again, this will be an integer, so we want that, and we'll want an integer slider. Steps this time will be 100, a minimum of 100, and I'm going to go 5,000 for the maximum, which is huge. You don't have to go that high if you don't wish to, but I'm going to go that high. A default will be 100, that's fine, and once again we'll clamp the minimum and maximum values. So that's our floor length dealt with. I'll add some data, and this one will be a separator. So we'll find where we can find a separator. Where is that? It's here somewhere. There it is, separator. No, not sound effector, separator. So I've got a separator in there. I'm just going to click separator line, and I won't give this a name. So that's in there. Moving on from here, we can add some more data. And this will be board width. This will be a real value, so I'm going to leave it as a float, and the interface will be float slider, a real value for the unit. I'm going to use steps of 1, but you can use fractional steps if you wish to. That's why I've put this in there. But I've chosen to go with 1. The minimum will be 5, the maximum 20, and on this occasion I'm going to go 15 for the default. And yet again, clamp the values. Moving on from here, we just need minimum board length, so we'll add some data. Minimum board length. This will be an integer slider. Steps of 10, a minimum of 10, and a maximum of 50. Default value we will leave at 10, clamp the values. Moving on from here, I'm going to command drag to copy this and rename it maximum. Maximum board length. Again, an integer slider, an integer data type. we want a step of 10, and this time we'll start with a minimum value of 60 and a maximum of 110. The default will leave at 60, and of course we'll clamp the values at 60 and 110. And that's it. That's our user data created, so we can hit OK. And there it is. We've got them. So floor length, I just need to spell that correctly. Let's sort that out. Double O. There we go. And there we go. We've got it all sorted. So those are all ready for us when we need them. And the next thing we're going to actually do is drag them into the editor. So we'll grab this rows. We'll say rows is equal to op, and then just indent that one in. That's got that one done. We'll bring in our floor length. Do the same thing. So we can say floor underscore length is equal to op, and then indent that. Bring in our board width. Same thing again. Equals op. And then finally our board minimum board length and maximum board length. So we'll bring those two in. Don't want to bring them in there. Let's just put a return there. Drop that there. And I'll call this min board length. Is equal to op. And finally max board length is equal to op. And that's great. That's all of our user data brought into the editor. Fantastic. So we've got our first two steps already complete, apart from one variable which we're going to put in later. But anyway, we'll continue from here and start coding our initial setup. We start with an if statement. So if frame is equal to 0, then we can think about what we're going to do next. Now the first thing I'm going to do is define a local variable called total. You'll see why a little bit later. So total is equal to 0. Then we can think about lengths and positions. So lengths will be equal to an empty list, and positions will be the same. We can then look at the children of our parent object. So as I said earlier, boards currently has no children, but here we're going to check to see if it has. So we can say if len children is greater than 0 for I in range len children, and then all we're going to say is children square brackets I dot remove open close. So at the moment this is irrelevant, because obviously if we get to this if statement now, it's not greater than 0 because children has nothing in it, because there are no children. But when it is, we will then simply clear boards out. That's what we're going to do. So if there's any children within boards, any children objects, we'll clear them out. We'll just remove all of them. And we need to do that when we're adjusting things in here. Moving on from here, I just need one more variable for now, and that will be remaining row length. And again, you'll see why I'm doing this a little bit later, is equal to floor length. So whatever value we've got in floor length here, so it'll be 100 at the moment, I've given that to remaining row length. Okay, so that completes the initial setup. Initially, I'm just going to concentrate on creating a single row of floorboards. I'm not going to do multiple rows at this moment. We'll add that later. So what we'll do is start with a while loop, and we'll say while, and we're going to say remaining underscore row underscore length is greater than 0. So all the time this row length, and we start with 100, remember, all the time this row length is greater than 0, this while loop is going to keep on looking at things and keep on processing things. Okay, so we can then say board underscore length is equal to random dot rand range. We're going to be using a rand range here, brackets, and then we'll look at our board lengths. We can say min underscore board length, comma, max underscore board length. And then to finish this off, we just need a step value, which is going to be 10. So we're going to be looking at these two numbers here, and in this case we'll be generating a number between 10 and 60 at intervals of 10. So it could be 10, 20, 30, 40, 50, 60. So that's what we're going to be doing there. Moving on from here, we need an if statement again. So we can say if remaining row length is greater than or equal to board length, remaining row length and it will be minus equals board length. So what are we doing here? Well, so if our remaining row length, so we start with 100, if that's greater than or equal to the board length that's been randomly generated, then we subtract that board length from remaining row length, which reduces it by the length of one board. Okay, so that's what we're doing there. We can then say else board length equals remaining row length. And we can then say from here remaining row length minus equals board length. So once we get to the stage where our board length, or rather our remaining row length, we can't subtract our board length from our remaining row length, because our remaining row length might only be 30, our board length could have been 40. So if that's the case, we simply say that our board length is equal to whatever our remaining row length currently is. So if it's 30, that's going to be our board length. We then subtract that board length from the remaining row length, which reduces the remaining row length to 0, and it will stop this while loop. So that's what we're doing there. And then to finish this off, we simply need to say lengths dot append brackets board length. And that finishes it all off. So when this while loop is actually running, all we're doing is generating random numbers which become our board lengths until we reduce our remaining row length to 0. So, you know, we're going to get X amount of boards depending on the sizes that are generated by the random numbers. And that's all we're doing here. And then all we do with these random numbers is use them to populate our lengths list. So that's how that works. It's quite simple. It's just pure logic. That's what we're doing there. Moving on from here, we've got to generate the positions of our boards and populate our positions list with them. Right, let's have a look at this. So what we need is to come back to here, and we need to say for I in range brackets len brackets lengths double close, and we can start thinking about what we're going to do in here. So for a start, we can say if I is equal to 0, positions dot append, and it will be int for integer lengths, because I don't want to work with floating values. It doesn't really matter, but I'm going to do that anyway. Lengths, and it will be 0 divided by 2. So my first position will be half the length of my first board. That's what I'm going to put into there. So that's a position 0. Okay, I can then say total, so this is where we're using our total variable, is equal to positions square brackets 0. So that's added to my total. Okay, moving on from here, I can say else, and it will be total is equal to, and it will be positions square brackets, and it will be I minus 1 plus lengths brackets I minus 1. So our first value is from positions, our second value is from lengths, minus 1, and it will be divided by 2, plus lengths brackets I divided by 2. So quite a lot going on here. So we need to get our positions, which we've got here, which is we will have position 0, or of course position 1, 2, 3, etc. So we'll be taking the I, whatever value of I, and of course it will be 1 because we've dealt with 0 here, so it will be from 1 onwards. We want to look at the previous position and then add lengths, and it will be I minus 1 divided by 2 plus lengths current value of I divided by 2. That's the formula for actually placing our floorboards end to end. That's the formula for actually making that work. We can then say positions dot append, and it will be brackets int, once again for integer, total, double close, and that's all we need to do there. We can look at this visually a little bit later on. Once we've actually got some floorboards in the scene and they've been placed end to end, we can take a look at how this is actually achieving that. But anyway, that sorts out our positions. Moving on from here, we can think about actually placing our floorboards into our scene. Actually, before we move on, I've just noticed that there's a couple of errors. I'm getting a get frame. There's an error in line 19 and one in line 48. Let's just check this out. So line 19, yeah, okay, I can see what I've done. I should have put brackets there. That should solve that one. And line 40, oh, okay. It should be minus equal. There shouldn't be a space between them. I should have just done the same as I've done up here. Right, now hopefully that's corrected those two. Let's just advance the frame and go back, and no, we don't get any more errors, so that's those problems solved. Let's just do a quick double check to see if everything is working. What we'll do, we'll print these variables. So if we print lengths, in fact what we'll do is name them. So we'll say lengths comma, lengths. And then we'll also print positions, comma, positions. Okay, so we've done these after the loop, so we should only get them once. Let's see if we actually do get them. So if we advance a frame and then go back, well, we're not getting anything, are we? And if we hit the execute button, we're still not getting anything. So why might that be? Because I'm sure that this code, or these two pieces of code, are correct. So why would that be? Well, it so happens that I do know, and I think I've probably shown you this in another tutorial, but it's worth reiterating. Now, if we look at our user data here, we can see we've got these orange bars. That's because the user data isn't quite set up correctly. It should be, and I don't quite understand why this happens, but anyway, if we just move these, we can see that it's instantly something changes here, but we'll move all the three and just get them set up like that, and now they are correct, and we can see now that we've got lengths and positions here. So we've currently got 3 floorboards because obviously we're using a very small floor length, the smallest available. But we've also got a local variable. So we've got a syntax error, so we need to deal with that. Another typo, another one of my bad typings. Here it is. It should be remaining, not reaming or whatever it says. Remaining row length. So if we clear that out now and we just do that, straight away we just get lengths and positions. So we can see that this code is working perfectly. So if you do get a problem with your code and you think, oh, I know the code's right, why isn't it working? If you're using user data as well, look out for the orange bars, and if you've got them there, just play around with the sliders and make sure those orange bars go away, and then you'll sort that out. Okay, that was just worth showing you that and reiterating it to those who already know it. But anyway, we can move on from here and start producing the code that will actually create our boards and place them under our null. Before we take the next step, I'll just comment these out because we may use them a little bit later. They may come in useful to us, but we'll comment those out for now. And we'll start bringing in this code to actually put the boards on the screen. So we'll say for I in range len, and it will be brackets length, or lengths I should say, double close. And then we can create a variable called cube, and this will equal c4d dot base object brackets c4d dot o cube. So it's O for object cube. So this is going to do what was originally in here. It's going to create a cube object, and it will initially be created with its default parameters, but we'll change those. The next thing we can do is insert this object under boards. So doc, and it will be insert object brackets cube comma parent comma none comma true. So we're inserting our cube under boards because of course boards is parent, that's the parent object. So that's where we're going to be placing this. As I said, that's what we need to do. Now this none and true, I don't fully understand how this works, but if we go into the developer here, the IDK, the developers kit, we've got base document insert object. So we've got what I'm using here, and we can see that it's self off parent. And then there's this pred, which I've set to none. Now, if we look at this note, it says if both pred and parent are provided, then pred has precedence. So that's why we're putting none where the pred variable is. So we'll leave that as none. And this is just to check names. Well, I put true because I don't want false in there because we do need to check the names. That's the way that I found this works. But as I say, I don't fully understand. I don't even know what pred means. Predetermined, predator, who knows? I don't know. It could mean anything, couldn't it? I don't know. It's one of those tech speak sort of words that's not fully explained, but somebody probably knows what it means. And if you do, then as I always say, please reach out and tell me because I don't know what it means. But anyway, we've got that done and that's fine. That's going to work for us. So we can move on from here. So let's see where we are. What's the best thing to do is probably to actually put a cube in the scene, because what we want to do is work with some of the parameters. So firstly, we want to drag and drop these into the editor here. So we want the X, Y and Zs. We will want to work with those, so we can drop this into here. In fact, that's not quite the way I want to do it. What I need to do is drag the actual X into here, because I need c4d.vectorx. So if you drag the size in, you won't quite get it the way you need it. Make sure you drag the X, Y and the Z in. So we can say here is equal to, and we need to put our variable cube, so we need a small c on the word cube because it's this that we're relating to. So we can say is equal to board width, because that's what we need our X value to be. It needs to be our board width that we've got in the user data here. So this is the variable that we're using. Okay, that's great. So that's done. We'll drag in the Y and drop it here. Just tab that in. And we can say, we'll just take that extra return out. With this, we can say equals 2. That's what I'm going to be saying for the height. I'm going to make that a constant. I don't want to change it, because when you think about it, floorboards are just thin planks of wood, really, aren't they? So we'll make them 2. Once again, need to put a small c on the word cube. And then finally, we need to bring in the Z. So we'll drop that in. Do the same thing again. And in the Z, we will say equals, and this will be lengths brackets or square brackets I. So this is going to take the lengths here as we're sequencing through them, and we're doing this here, and we're going to be using those to create the lengths of our floorboards along the Z-axis. So that's what we're going to be doing there. Cube is not defined, 71, where are we? I don't think we need to worry about that, or forget about that for now. Okay, so we've got that far. The next thing to worry about is actually a fillet. So I do want to use a fillet, and I will want to play around a little bit, or maybe play around with my fillet radius. But first thing to do is actually drag in this fillet here. So we've got, again, cube, because we're working with our cube. So we want to do the fillet, so we need to say equal to, and it will be true. So that will check this box for us. Okay, so we'll just check that on so that we can now work with the fillet radius. Now let's have a look. So the fillet radius, what am I going to make the fillet radius? Yes, it does want to be smaller than 3, so I'm going to drag that in. Oops, don't want to do that. Cube, that's it. And we'll say equals 0.3. We only want a very small fillet radius on there. And that's as much as we need to do. We'll leave the subdivision. You can drag that in as well and change it if you wish to, but I'm going to leave it as it is. 3 is fine. So we've got the next part of it done, and now we can think about adding a Phong tag to our cube. I mean, obviously it's not going to be this cube, it will be a different one, but we need to add a Phong tag. So we're going to add this over here. The way we do that is to create another variable called Phong. So we'll do that, and we'll say Phong is equal to, and it will be c4d.base object. And this time we're creating a tag, so it's actually not base object, it's base tag. Should have said base tag. Brackets c4d dot t Phong, if I spell it correctly. There we go, t Phong, and that's in there. So that's created a Phong tag. Now we need to apply our Phong tag, so we can say cube dot insert brackets, it's insert tag actually, insert tag brackets Fong. And that will place our Fong tag on our cube. So that's our next little piece of this done. We now need to set our relative positions of the cube so that we can place them on the screen, and we're going to use the positions here to do this. So with our cube selected, we can come to coordinates, and this is what we're going to be interested in now. So we'll drag in the X to here. And again, I've dragged the X in because I want the position vector X. I want this here, this C4D dot vector X. And now we can think about where we're going to place these. So initially we're going to say for the X is equal to 0. So that's our X-axis, because we just need this at the point 0 because we're only doing one row at the moment of floorboards. We can bring in our Y. And again, let's just put our small C's on the word cube. And of course, in the Y-axis, we don't need to move at all. We don't need to go up or down. We just need the floorboards to sit on the floor. So they can just be 0. So that's fine. Drag in the Z. Small c on the word cube. And this will equal positions, brackets, or square brackets, I. Because obviously the len here will be the same for both positions and lengths. We've got exactly the same numbers of values in here and in here. So that's working okay for us. Right, that's great. So we've got that set up so far. Let's remove this cube. And we can see that we've got something in the scene. So let's just zoom in and see what we've got. And we can see that we've got 3 floorboards. They're actually positioned, and we can see that they've got fillets on them. We can see that they're 2 in height, they're 15 in the width, and they're taking their lengths from the length or the lengths list. And the positions are correct because they've been taken from the positions list, and they're all placed end to end. So if we just uncheck these, or uncomment them and execute, we can see what we've got. So we can see that our first length is 10, so this will be 10 in length. The next is 50, and the next is 40. And that adds up to 100, because of course in our Python generator here and in our controls, we've got 100 as our floor length. Now, the boards are all cubes that are procedural, so their axes are in the centers of them. So the first position does need to be 5, because this is the 0 point, so our first position is 5. That places it correctly so that we're coming from 0 to 100 over here. That's what we want. So the next position is 35 because of the way we've set up our formula for our positions. So we said that we wanted, our first one, we said we wanted to divide its length, which would be length 0, which is this length. So this 10 is length 0. We wanted to divide that by 2, and then that would give us our first position. And then moving on from here, we said else. So our next position, we looked back at this first position. We got that position and we wanted the whole thing, so we just used 5. We then added half of our first length. So we divided that by 2 and added half, and we added half of the current length, which is this here. So we ended up placing this at 35. That's how we did this. And the same thing applies, of course, to any subsequent boards. So that formula is used, and it places the boards end to end, and it makes sure that they don't exceed the total length. Because the last board, of course, is worked out up here in the lengths. It's the remainder. The last board is always going to be the remainder of whatever this number is, minus the preceding board's lengths. So that way you never exceed the floor length, and you always make sure that you place the boards end to end by using those simple formulae. So that's what we're doing there. And yeah, it all works really well. It works out beautifully, actually. So great, that's all working fantastically. But obviously at the moment we've only got one row of boards. We do need multiple rows of boards. So we need to put a for loop up here above this while, and that's what we're going to do next. Right, let's make some space here and put our for loop in. So it will be for row in range brackets rows colon at the end. So that's our for loop installed, and we can now create multiple rows. What we need to do is work with our X vector here, because obviously the rows are going to be placed along the X axis. And we can say board width multiplied by row. So that will give us our rows based upon the board width, so they'll be spaced 15 units apart. Okay, in order to finish this off, we've still got to do a little bit more work. So we can come down to here and come to our indent here, just back one level, and we can say lengths dot clear positions dot clear, and finally remaining underscore row underscore length is equal to floor underscore length. So that resets everything. So once we've done one pass through this for loop, because we've created the boards here, we can just clear our positions and our lengths, and then reset our remaining floor length, or row length I should say, back to floor length, so that we're ready to start the next row. Okay, that's all we need to do. Great, so let's just see if this actually works, and we can see that it does. We're getting different patterns within our rows of floorboards with each pass. So that's working absolutely the way we want it to, and of course we can increase our floor length so that we get even more boards. And yeah, it's all looking really good. We can change our width and everything reacts accordingly. And of course we've got the other two controls, the minimum board length and the maximum board length, and we can change those to change the art direction of what's going on. So yeah, everything is working the way we need it to work. Now the only thing we need to do next is to add a texture, just to finish this off. So that's going to be our next port of call. Let's just open our material window, double click in there to create one, and let's see what we've got. I'm not going to bother with reflections. I'm just going to do a basic texture for this. You can go a lot further if you wish to. In here, I'm going to use a variation shader. That's the one I want. Click on here, and then we can decide what we're going to do with it. The seed we can just leave as it is. You can change that, of course, if you wish to, but we'll leave it for what it is. In texture 1 here, I'm coming down to surfaces, and I'm going to choose wood. I'll leave the wood the way it is for that particular surface. And in my secondary texture, surfaces, and again I'm going to choose wood, but this time I'm going to change the type from walnut to pine wood. And that's as much as I'm going to do in there. I'm not going to go mad with this. So I've got those two done. Let's just go back into here. And random color I'm going to set to 0 because I don't want to see that. And in the UVW shift here, I'm just going to say 2, 2, and 2. And then finally in the scale, 0.2, 0.2, and 0.2. And that's as much as I'm going to do for now. So in the variation shader, we can see that we're going to get an interesting result. It should be okay. So we'll close that down. So I've got my material in. Now we need to go back to our code and do some more work in there. The first thing we need to do is make a little bit of space here. We'll just do it under children, and we'll say materials is equal to, and we can say doc dot get materials, open close. and that will get all of the materials that are in here. I mean, we've only got one, but it could be multiple materials. So in other words, it creates a list of materials. So that's that so far. Moving on from here, we can code down here, and we can say texture is equal to, and it will be c4d.base tag brackets c4d.t texture. And this is similar to what we did with the Fong tag. It's going to create the actual tag for us. So that's all we're doing there. We can then say texture dot set material, and then it will be brackets materials square brackets 0 close square brackets. So in other words, it will get the material that we've got here and set that on the actual tag. That's what we're doing there. Our next line of code will be texture, and here what we need to do actually is place this just on boards for now, because what we're going to be interested in is this projection menu here. So we'll grab that in, just place it there, and in this drop down menu here we've got a number of options. So we've got spherical, cylindrical, flat and cubic. So we need to choose the projection type that we wish to use. Now, I know that this index value here will be 0. So 0, 1, 2, 3. I want a cubic projection, so I can say is equal to 3. Now, before we go any further, it's worth reiterating this because I have mentioned it before, but drop-down menus, just because this has an index value of 0, this is not written in stone. Some drop-down menus don't start from 0. They start from, well, it could be any number, I suppose, but the essential thing is that they don't always start from 0. So if ever you're working with drop-down menus and you're not quite getting the result you think you should be getting, it's probably because of the numbering system. On this occasion, we're lucky. This does start from 0, so cubic is definitely a value of 3, but it's not set in stone. Okay, right, let's move on from here. So our final line of code will be cube dot insert tag brackets materials, and that's all we need to do. In fact, not materials, I beg your pardon, it's texture. And that's all we need to do to finish this off. So now we've got our texture inserted, or it will be inserted on all of our cubes. We'll just remove this from here and we can see that's already worked. There they are. So we'll remove that from the boards because we don't want that to influence anything. And that's it. That's all we need to do in the code. That's completely finished now, and this is working the way we want it to. So we'll just shut that down. In fact, we'll go back to a standard layout for this, because what we'll do now is just take a quick render. And there you go. We can see that we're getting a really nice looking floor. And if we come back into our Python generator here, go into our controls, we can now experiment with this to our heart's content. So we can make it longer, shorter, whatever we want to do. Maybe make our board width a bit longer, add a few more rows. Or alternatively, we could reduce our board width and add a few more rows. Plenty of things we can do. And then, you know, just see what we've got. Let's hit H so that we can see that, and then take a render of this floor. And there you go. It all looks really nice. It gives us a really nice looking result, doesn't it? But that is how you go about creating a floor generator using the actual Python generator. So that brings us pretty much to the end of this tutorial. So as always, I really hope you've got a lot out of this one, and that you can see certainly how powerful this Python generator really is. I mean, it's quite clever once you get into it. And when you think about it, if we go back and look at the code, it's mostly, or at least a heck of a lot of it, is just drag and drop. I mean, this is all drag and drop. And down here, this is all drag and drop stuff. Yes, we've had to do a bit of mathematical working out here, but it's actually relatively simple when you get into this stuff. And you understand how it actually works. But very powerful, as I say. And when you think about it, there's not much code there, is there really? Not that many lines to actually make this work when you consider just how deep it actually goes and what it actually allows you to do. But anyway, that about brings us, as I say, to the end of this tutorial. So we'll bring the curtain down on this one. And if you have enjoyed the video, then please give it a like. And if you haven't already, then please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, then please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, I'm going to bring this one to a close. So I'll see you very soon on the next tutorial.